Hi YouTube! Tonight we're going to nerd out about torque tools. What are torque tools? They are tools which allow you to apply a selective amount of torque to a fastener, such as a screw, nut, or bolt. Now, why would you want to apply a select amount of torque to something? On the upper end of your torque range, you have automotive, construction sector type applications where you want to make sure something doesn't fall apart under vibration. The easiest example, especially if you're Canadian, is if you have snow tires. You want to make sure that it's torqued down to the correct torque value so your tires don't have the lug nuts fall off on the road and your tire doesn't do a dance down the highway as you start to spin out and get into a terrible accident. This is an automotive application 3/8 square drive torque wrench from I think like 10 to 80 foot-pounds. I'm not going to talk about this because I think this falls outside the intention of this video. So I'm going to set this aside. The intention of this video is to talk about the application of torque tools on the lower side of the torque scale. Typically you want to avoid over-tightening a fastener where you could strip out a component, strip out the threads in something and cause damage that's irreparable or very hard to repair depending on how small the machine thread is. What we've got here are two different torque screwdrivers and a connector wrench, and I'm going to talk about the screwdrivers first and then this connector wrench a little bit after. So we're talking about not stripping out fastener threads, for instance. Why would you want to avoid doing that? Well, it's hard to repair fastener threads. Anything that's maybe a 1/4 inch and up, you can repair with these things called helicoil inserts where you drill the hole out, re-thread it to a larger thread, and then use a special tool to insert a spring steel coil that gives you a thread again. It's a lot of work, and it's really only if it's a high-value object. For makers, one of the most common things that you'll want to do is you'll want to 3D print something, and you'll want to have machine screws holding the thing together. There are 3D printed parts here with heat-welded PEM inserts. These inserts here, for this example, are M3. They have a very fine M3 thread on them, and it doesn't take much torque to strip these out. If you were to apply an M3 screw directly into a 3D printed part, you would strip out the threads on the part that are just cut into the plastic. But if you put one of these inserts in, you could strip either the screw, you could strip the insert, depending on how bad quality the screw is, or you could damage the part on the surface. So typically you don't want to over-tighten. At the same time, you don't want to under-tighten as well. Clamping force, when you have a screw and a nut and you tighten them together, the clamping force, you can look up engineering tables that specify how much force is applied when you tighten the fastener to a certain torque. And that allows you to hold two pieces together with a certain amount of force, and you can calculate, okay, if I've got that much force holding them together, is that enough to keep it from shifting around under vibrational load? All that aside, huge tangents and I digress, let's talk about these two tools. What do I have? I got a Wera 7445 adjustable torque screwdriver in inch-pounds, and I've got a Wera 7461 fixed adjustable torque screwdriver, and that's not a slip of the tongue, a fixed adjustable torque screwdriver in Newton meters. So, nerding out about Wera tools for a brief moment, they make really good quality hand tools, great fit in the hand, good quality plastic, solid construction. These will last you for a lifetime. So honestly, if you have stripped out enough fasteners in your life, I'd recommend just saving up, biting the bullet and getting one of these, as well as a 1/4 inch hex drive Allen key set, or hex head driver set, and going to town, because then you'll never strip out a fastener again. Okay, so in terms of the Wera tools themselves, they come in these really nice twist tube packaging configuration. I don't even know what to call it. But the most important thing is when you buy quality, you get a C of C, or a certificate of conformance. Effectively, it's saying, we've tested these tools to a certain specification. Here is a specification and our stamp of quality saying that it does what it's supposed to do. Because really what you're talking about is, this is a metrology instrument of sorts. You're measuring torque indirectly by tightening something to the point where your torque screwdriver tells you torqued it correctly. It's like a caliper or micrometer. You want to make sure that it's calibrated correctly. Otherwise, you're going to be assuming it does the correct thing when it isn't. So, I mean, here you're going to see that it's calibrated under a certain ISO guideline, using a certain piece of test equipment with a certain measuring sensor right down to the serial number, measurement uncertainty interval, maximum measurement error, and all these other parameters that I suppose influence the test results. Wera is, again, very good quality in terms of their equipment, so there's really no excuse for these tools being off calibration from the start. Now, after you use them for some time, they may lose their calibration and you may want to get them recalibrated. So it's always handy that these tools are uniquely serial numbered as well, so that when you send this in, you can say, for this particular tool serial number, you had it recalibrated, and the CFC will match, because that's the serial number and that's the serial number there. So, always important, keep your CFCs. Always want to refer to them and how well it was calibrated sometime down the road, especially if you're in a manufacturing environment where you have to prove the quality is baked into your product, that you use tools like this to effectively guarantee quality and consistency within your products. So this is the adjustable and this is the non-adjustable, or I should say fixed adjustable version. The adjustable version is interesting. All you really do is you pull this collar back, and I might have to get a close-up view here. You pull the collar down, and then you twist the tool, and it has a detent in it that basically allows it to settle in one of two positions. And you'll see here that the scale on the screwdriver starts to go up. So now I've dialed in 4 inch-pounds on this screwdriver. There's a little arrow that is visible. Oh, backwards here. There's a small arrow that's visible. So all you do is you pull that back to adjust the torque on this. And in this case, you can adjust it from anywhere between 2.5 and 11.5 inch-pounds. You can measure in inch-pounds or Newton meters. You can convert between the two of them. It's really what is your application and what is the most practical thing for consideration. Go back to my other camera here. Alright, so actually I'm gonna, that camera, cool. So in this case, you can have an adjustable torque wrench, or adjustable torque screwdriver, or a fixed one. Different reasons why you want each. In my applications, I use the adjustable one for everyday use. I will adjust it up and down. I have to switch them around. I'll use the adjustable one for everyday use. I'll adjust it up and down to the target range and tighten my fasteners using this. While I can use a conventional fixed screwdriver and tighten it to, well, that looks good enough, if the specification exists on the component or the part, I'll try my best to adhere to it, and I'll use a torque screwdriver to make sure I'm not over-tightening it and stripping the threads. Because if you over-tighten it and you start to weaken the threads on a fastener, you reduce the clamping force. That can matter in electrical connectors, where if you over-tighten them and you reduce the clamping force on the component, it can actually start heating up more. So it's very common in the electrical sector to see inch-pound torque measurements, and this is why I have both Newton meter and inch-pounds. So I use this for my everyday work at the workbench whenever I'm tightening fasteners. The fixed adjustable, this one is a factory set, other camera. This is a factory set 1.2 Newton meter torque screwdriver. There's no adjustment functionality on the outside. So why is it considered a fixed adjustable torque wrench? Go back to my overhead. So this is pre-calibrated to 1.2 Newton meters by the head stamp on the back here, and if I go into the tube that actually came with this, I can dig out a couple spare caps. They aren't stingy at all. They actually give you 5 spare caps here, and I'm sure you could, ask them for more and they just mail you some, because, they're a good company like that. But the idea is that it's preset to a certain torque, and if you need to change the torque, you can pry the cap off with a screwdriver, go in with an Allen key and change the torque value while testing this on a calibrated instrument. Once you set it to the correct torque value, you can recap this, engrave or otherwise mark the preset torque value on here, and again, because it's got a unique serial number, you can generate your own COC if you have the facilities to calibrate it, or send it out to get calibrated and get a COC back with it that says that this screwdriver is now calibrated to a certain amount of torque. Why would you want to do that? Say you are in a factory or assembly line that uses hand tools to tighten fasteners down, or you only want to ever tighten fasteners down to a certain amount. Say you want to give this to someone who doesn't have the time or inclination to read a data sheet on a component for torque value. Well, you hand them this and you guarantee they can't over tighten it, right? This inherently makes it foolproof in that you cannot over tighten it, which is really useful because in a pinch, I know that 1.2 Newton meters is a little over 8 inch-pounds of torque, which is great for M3, M4, M5 fasteners. Sure, it's not the perfect amount of torque to apply to those fasteners, but in a pinch, when I just need to get it tightened down in the field, I can throw this into my tool bag and not worry about it falling out of calibration or anything. It's there, it works, it's good to go. Not the best in terms of accurizing like an airsoft gun or a firearm, because you would ideally want an adjustable one that can go quite higher than the two ranges on the table here, but still very useful. So these are the adjustable torque tools. How do they actually work? Well, why don't I just demo this? I've got this other janky looking contraption that I'll get to in a minute, but in the Wera screwdriver case, you just kind of, when the collar is forward, you just apply it, insert the bit, it clicks back, and as you're tightening the fastener, it will click when it hits the preset amount of torque. So if I increase the amount of torque on this screwdriver to 4 inch-pounds, it needs a bit more force. And then I can keep going all the way up, probably to the point where I can't even hold on to the bit. Now this is 8 inch-pounds of torque. It's actually getting quite a bit more difficult to hold on to. And all the way at the top end of this, what is it, 11.5 inch-pounds of torque? I can just barely hold on to it with my left hand. So you can dial this in and it works great. Pretty simple, pretty foolproof, not much more to it. I'm going to leave this at 8 for a demo in a moment. Same thing applies with the fixed torque screwdriver. All you do is you just tighten your fastener down. Once it starts putting resistance on, you go till it clicks and you're at your predetermined torque limit. That's it. Simple. Hard to mess up. So why do I have this janky looking contraption? Well, there are other reasons why you want to have a torque wrench other than just tightening down machine screws or other fasteners. SMA connectors for radio frequency applications, you can over tighten them, you can under tighten them. Ideally you want to hit the correct amount of torque so that you don't strip the fastener, but you also don't leave a high impedance signal path. I'm just looking through my connector bin here, not my connector bin, pouches. Here's an example. I have a, yeah sure, let's set it to an end connector. I've got my RTL SDR. I keep a little storage cap on the end there for safety. And I've got this connector that I want to connect onto my software-defined radio. You would hand tighten it on first until you have it most of the way there, and then all you do is you use this SMA wrench and tighten it till it hits the predefined torque limit. And when it hits the torque limit, it collapses. It's a little bit cheaper than your click type with an audible indication, or the automotive style click wrenches where when you apply a certain amount of torque, you'll hear a click coming out of the head, and you might be able to see this on camera where it deflects. It's a very small amount of deflection, but it does click. And this is actually set at the minimum torque range, and it does take quite a bit of force to click that by hand. The collapsing wrench style is cheaper. I think this only cost about $30 on AliExpress For better or for worse, it's still better than going 900-pound gorilla on this little tiny SMA connector and a open-end box wrench. Like other torque tools, these come with certificates of conformity. How much I trust these CFCs coming out of China off of AliExpress for $30? Well, not that much. But what does it say? It says that this specific serial number, 2005-1349, right? Oh, you can't really see it, but it is laser engraved on the anodized aluminum body of this wrench, is set to a spec of 1 Newton meter, and I'm guessing that these are bracket values and a certain % error measurement, so it has to fall within 0.98 and 1.03 Newton meters, and they would adjust it by adjusting this screw here. Now, ideally, once adjusted, they would put some sort of a sealant or a cap here to make sure that you don't inadvertently mess with this value, because if you do, this is useless. So when I got this SMA torque wrench recently, I went and thought, how can I prove, or at least sanity check without access to a high-end torque measurement device, what this is calibrated to? Well, I have another torque screwdriver. In fact, I have a torque screwdriver that I can set to about 8 inch-pounds, which is close to 1 Newton meter, and I can check it. Right? Remember that if I turn this way, I can get the click when I hit the necessary torque. So all I've done is just jury-rigged one torque wrench to fight another, and that's about 1 Newton meter there. I'm going to reset that. If I turn this down a notch, and if the demo gods are willing, because this is on video, I use this torque wrench. Oh, no. Yeah, no. Demo gods, let's turn that down one more notch. Really? Interesting. Yeah, okay, there we go. So I'm just holding the screwdriver steady, and I'm applying a constant force on the wrench, and it causes the screwdriver to click. So this torque here is exceeding this torque here. Now if I turn this back up to 7.5 inch-pounds, the wrench collapses. Sometimes. So it's like right at the limit of where that is set. Turn that one more to 8 inch-pounds, and this should almost guarantee the wrench collapses out. Yeah. Yeah, once every so often. So you throw that into a converter or calculator that just converts between inch-pounds and Newton meters, and this is close enough. For the purposes of SMA connectors, this is still better than just tightening it by finger or going ham-handed with an open-end box wrench. And it certainly beats the pants off of stripping a connector on something, you know, as expensive, air quotes expensive, as a software-defined radio or other complex piece of equipment. I mean, I've got my Hack RF in this pouch as well, and I don't want to strip that out, so, you know, better to do that than waste the time having to repair your equipment because you didn't use the right tool. So again, we're back to the fundamentals of we don't want to damage the equipment. So one last note about torque wrenches, or torque tools in general. You want to avoid leaving the torque tool set to a particular torque and then throwing it into a bin for storage. It is the cardinal sin of torque tools. This is only applicable to tools that have a click or a spring setting. If you have a deflection beam style torque wrench, or you have an electronic torque wrench with a load cell, this rule doesn't apply to you because you don't set the torque with a preloaded spring adjustment. But with the tools that have preloaded spring adjustments, you want to avoid leaving it set to a torque for prolonged storage, if you can avoid it. Tools with fixed torques are designed to basically stay in storage as is without losing calibration. But these style tools, you want to turn them all the way down before you store them. And store them at the minimum torque setting so that you don't compress the spring, because the spring in here, however it's configured, is what gives the torque preload. This is not a situation where you need to relieve the spring tension, because it's designed to have a resting spring force that's tolerable, and then only when it exceeds the torque does it push on that spring. Whereas this one, you tighten the spring up and you leave it there, it may change its torque response. Same thing with large torque wrenches. You want to store them with the torque setting backed off all the way, just to avoid over compressing that spring for prolonged storage. So I think that's this video on torque tools from the small scale standpoint. This really wasn't a review video about Wera tools. This is more about, you know, why do you want torque tools? Why would you want to use expensive screwdrivers for $100–150 when you can buy a $10–20 job and get the job done? Because you don't want to damage your equipment. You don't want to damage the fasteners or the threads in your part, because it takes time to make those parts, and frankly repairing them or replacing them just isn't worth the effort in a lot of cases. So then you end up throwing the component out. If you do the job right with the correct torque specification, you'll never go wrong. So that's my piece on this. Take it as you will. Have a good night.